In this video we're going to look at a new topic, structural forms, which is question C2. It's one of the option questions, and we're going to look at the hyperboloid of revolution within structural forms. So this is a hyperboloid of revolution. It is a surface that has been created by rotating a hyperbola about a central axis. So this is our hyperbola. This is the vertex of the hyperbola, and as it rotates around the middle axis, it forms our shape. A few important things to know about the hyperboloid of revolution is that it is a ruled surface. A ruled surface is any surface where you can draw a straight line on it, and in this case we can do that. Each of those lines are called elements. So this here would be one element. So I have a line joining from the top going down to the bottom, but if I change my view, in the elevation I see my line, and in plan this is the same element also. Now this line is tangential to the throat circle. So the throat circle is this green line here. It is the narrowest circle on our hyperboloid of revolution, and all our elements will be tangential to it. So every straight line that goes along the surface of our hyperboloid of revolution will touch off of that throat circle. So when it comes to us drawing our hyperboloid of revolution using the elements method, I'm able to put in a number of these elements. They're all tangential to the green line, and then up in the elevation they form the surface. So if I hide the surface just for a moment, I get all these elements which will form the curve in here for me. So how do we do that on our question? So if I swap to the question, so here we have the same style setup. I've got my large circle for the top and the bottom, the throat circle which is the middle point, which was the green line, and then in the elevation I have the same, the top and bottom, and then this is the throat circle in here. So the throat circle would be, I'll just darken it in green. There was no physical line there, as it's the interior, it's what's left in the middle. So to find this, what we're going to do is we're going to draw a number of elements, and as I said earlier, an element is a line that is tangential to the throat circle and touches the top and bottom points. So I'm just going to draw a line. These are random lines drawn in here, touching the outside circles and tangential to the throat circle. I need to find that same point in the elevation, find that same line. So this point touches here. So if this is up high, it's touching this point down here, and it comes down to this point which is down low. That's one of my elements. Now this line here could also represent another line. So instead of it just being going from top to bottom like this, it could also be the same line going the opposite direction, coming down. So again, I can put in another element there. So all we're going to do now is we're going to continue putting in elements. So the elements are going to be random lines drawn that are tangential to my throat circle. Again, each one is going to have two positions. It's going to be up high and down low. And it's important just to do these one at a time. Don't go trying to draw 3 or 4 of them at a time. It gets confusing, and then you draw your wrong lines in. So there's one. Pick another one. So all we're doing is drawing lines tangential to the throat circle So the more lines that we put in, the better our curve starts to form. So if I put another one in here, so high and low point. This is the slowest method that we have for drawing the Hyperboloid of Revolution, but it does give an accurate, somewhat accurate representation of it. So I'll just maybe put in one more. So each time that we put in a line, it's adding and making our curve more accurate looking. So each one that I put in here. So now what we have is we have a number of lines up here that are starting to form our curve, just like we had inside in the SolidWorks model. So what we can do here is I can take each one of these, and each time it's in the middle of a line, not where two lines touch each other, but in the center of the space between where lines touch, I can join up those lines, and this will form my curve for me. And that is one side of the curve. Continue doing the same number, or the same thing on the opposite side with the number of elements. And we'll end up with our curve on this side over here. So that is our elements method for drawing a hyperboloid of revolution. The second of our three methods is using the information that a hyperboloid of revolution is formed by a hyperbola rotating around an axis, as I showed earlier. So the curve that we have on the right hand side of this black curve, is a hyperbola, and you have another curve here on the opposite side which is also a hyperbola. So we're going to use the method that we used for constructing hyperbolas as in the conic sections chapter. So what we're going to look at now is how we set that up, how we do it. I've used the same type question. I have 66 up here on top. I've changed the throat circle diameter just to 36 to make it a little bit easier, and then 66 down here again. So the method for creating this is the rectangle method that we used in conic sections. So I'm going to draw my rectangle off out here on the right hand side, and our rectangle is in this area in here. So this is one of our rectangles. This would be the other one for the other half of that same curve. I have the same on this side. So I end up with two large rectangles, and then a bit of an axis going across what would be the normal axis for the hyperbola here. I'm just going to label a couple of points. So this is point A, and this is B, the top of it. Point C is the point on the axis here in the middle, and this is V1 and V2. These are the two vertices that I need. So to draw my hyperbola, I'm going to divide the line AC up into a number of equal parts, and I'm also going to divide the line AB up into the same number of equal parts. So the line AC is 55 millimeters long, and if I divide that into 5 parts, I'm going to get 11. So I'm going to mark off 5 11 millimeter sections. And I'm going to label them 1 to 4 starting from A. Going up the side, A to B is 15 millimeters, and if I divide that into 5, I'm going to get 3 sections. So again, I'm going to 1, 2, 3, 4. Now, for here, what we need to do is we need to join our lines to the different vertices. So the line AB, the points there, the lines which are parallel to the axis, are going to join to the near vertex. So these ones here, they're parallel to my axis, which is this one, so they're going to join to the closer vertex. So these join down along this way, all light lines. The ones that are perpendicular to the axis along the line AC, they join to the far away vertex. And where each of the lines cross each other, so where the 2's cross each other, the 3's cross each other, the 4's and the 1's, they form points in the curve that I'm looking for. So where the 1's cross, 2's cross, 3's cross and 4's cross, they're all points in my curve, and I can now draw the best curve that I can from A through to those points up to V1. It's the same on the opposite side, or the other side of this curve. So these can be mirrored across, or you can redraw it. So I'll redraw this one. So again, label the points. This is A, this is B, 1, 2, 3, and 4, 1, 2, 3, and 4. So 0 or 1 is always farthest away from the vertex. So 1 joins to our vertex up here, 2, 3, and 4. And these ones, the ones that are parallel to the axis, join to the close one, vertex of this actual curve. So 1, 2, 3, and 4, and the best curve that we can that touches each of those points. And that gives me one side of my Hyperboloid of Revolution. To find the same points on the opposite side, you can use an axial symmetry. So if I was to take this point here, across my axis, measure the distance that it is on this side, same distance on the opposite side, that's 1 point. Do the same thing for the others. So measuring the distance from my axis to the point, and same distance on the opposite side. And then we can draw the best curve that we can for each of those points. And that gives me the bottom, that part there. And if you do the same thing up on top, with our other part of our curve up here, that will complete the Hyperboloid of Revolution using the rectangle method. So in our rectangle method, we are drawing two hyperbolas based on the conic sections constructions that we use. The third and final method that we have for drawing the Hyperboloid of Revolution is the asymptote method. So the asymptote method is something, or the word asymptote is something you may be familiar with from maths, and an asymptote is a line which is seen as a true length in the elevation. So our asymptote is an element that is found and it appears as a true length. So for it to appear as a true length, it needs to be horizontal in the plan. So that is going to be this line running across here. So this is one of our asymptotes, this line. That appears as two lines as the other elements did previously in the elevation, crossing here. And asymptotes always cross at throat level. So they always cross on the throat circle. So if this is my horizontal line, these are my elements, this is the elevation of it, they are also elements. Asymptotes, as you know from maths, are lines that get close to the curve but never actually touch it. So an asymptote is found, in this case, as a line that cuts the curve coming down along this way. So it touches it at the throat circle and then comes down along here to meet it. So let's find them first in our drawing page. So to do that, I'm going to take a line that is parallel to the x1, y1 line, and that touches the throat circle at either the front or the back. So it doesn't matter front or back, but we'll use front. Just a little bit easier. So this is our asymptote in the plan. In the elevation, that is going to be two different lines, one starting high, one starting low, the other one going the opposite way. So this is one line, this is one asymptote going from here to here, across the throat level, and going from here to here, and also crossing here at throat level. So what we're going to do next is we're going to use our asymptotes to find our curve. So this is essentially using horizontal cut sections through each point here. So if you were to cut this shape, it gives a circle. So if I cut it at different levels, it gives a circle. Cutting it through the middle gives us the throat circle. Up top gives us our top circles and other circles in between. So what we're going to do, if I swap back to the SolidWorks model, is I'm going to cut this at different heights. So I'm going to put in a horizontal cutting plane, and that horizontal cutting plane is going to result in a circle. So this is one horizontal cutting plane. The height of it does not matter, and in plan that is going to give me a circle. So the radius of the circle, if I find this point here, I'm going to bring this straight down until it touches the asymptote. That's the radius of my circle from here to the center, and I'm going to rotate that around until it comes to here, until it comes to horizontal. Project that straight up, giving me this point here. I'm going to have a line coming straight up, and the line, the circle, if I draw the circle then in the elevation, it gives me that point. So they're going to intersect. So we'll have a look at that now on our board. So I'm going to take a horizontal cut section anywhere here. So I'm going to cut it here. I'm going to find where this point is down in plan. So it's going to be on the asymptote. So I'm going to project this line down, and it's on the asymptote. So that gives me that point there. I'm going to draw this circle. So the resulting cut section. Okay, so I'll draw the whole thing just for this one. So the radius is going to be from this point to the center, and I'm going to draw that circle. Now I need to find that same circle up in the elevation. So this is going to be a point on my curve, on what the curve appears at here at the side. So I'm going to project that one up, and it's going to intersect this point here. So that is going to be a point on my circle. So that there is that circle. Going to do the same thing now for a couple of other points, other locations. So I'm going to draw one here. Find this point down in plan. On my asymptote that's here, I'm going to draw this cut section, what this section is going to look like. It's going to be circular. So that's going to come around until it touches off the line, the horizontal line going through the middle of it, because when it's touching this is where the curve is up here. My hyperbola here on the side is located there of what I can see. So rotate that around until it's into that position, till it's horizontal. Then bring it up to meet, and that gives me that point up there. I'll do one more just up above the red one. So find this down in plan. So project it down onto the asymptote line. I'm going to rotate it around until it's horizontal. So they're swinging this way. And I bring it up then to intersect the horizontal cutting plane that I have, giving me that point. So I have a number of points there. This is the throat circle, and I can join each one of these up here. forming the top part of that curve. Can do the same thing down at the bottom. So these points would also be the same points down low. So if we cut it there, it's also going to cut it down here. And that one is on this line. The next one cuts it at this point. And finally, this one cuts it here. So I can join these points up, getting the curve on the lower part of it. And there we have the asymptote method. So for the asymptote method, what we're taking is we're drawing our asymptotes, which is an element, but it's a true length element. So in elevation, I'll have true lengths. In plan, it's going to be tangential to the throat circle, but it'll also be horizontal. So it can be here or at the back. I take horizontal cuts through it, and that's going to give me circles, circular sections. I find where they cut the asymptote in plan, so I follow my line down, I cut it, and it cuts it here. I draw in rotate it around until it's horizontal, so that gives me this point, and project that back up and until it intersects the horizontal cutting plane, giving me the points there. So here we have three different methods for drawing the hyperboloid of revolution. We have the elements method, where we take random lines tangential to the throat circle, find them in the elevation, and number them together will start to form the curve. The second method is our rectangle method, where we are using the construction for the hyperbolas that we used for conic sections. And the final method is the asymptote method, which is again using two elements, except these are special elements as they're appearing as true length lines in the elevation, and then we're going to take horizontal cut sections through each point. So if we take a horizontal cut section through each of these, it ends up as a circle, and then we locate them up in the elevation.